Thank you. All right, reflexive property of congruence. We talked about reflexive property in terms of algebra, but the reflexive property of congruence, kind of a weird one, but it basically says that if I have segment AB, it's going to be congruent to itself. There's also the reflexive property of congruence for any angle. This is really weird to think about when you aren't used to writing proofs, but if you look at an image and you have to use a segment within two different figures, you have to use the reflexive property of congruence. This is where proofs get very tedious because you have to add things in that aren't intuitive. We don't think that way. But we have to have these statements in there to lead to other statements. So this statement, it feels like it's not needed, but we actually do use it quite a bit.
Wait, is that what the sign? I can't exactly see what that
It's a congruent sign. It's the equals with the squiggly on top.
Oh.
We use that when we're talking about figures versus we're talking about numbers. 3 is equal to 3 would be the reflexive property of equality. Everybody okay so far? All right, then the symmetric property of congruence says that if segment AB is congruent to segment CD, what would the symmetric property want me to do? We just used it in our algebra. Flip it, very good. Then we can say that CD, segment CD, is congruent to segment AB. So it just allows you to switch a statement around. Hold on a second. Did you have a question or are you just writing? I'm writing. Gotcha. There you go. All right, now my favorite one, transitive property of congruence. This is where you have a common link between two things and you can link it together. So if I say something like AB, segment AB, is congruent to segment CD, well, let's say I also know that segment CD is congruent to segment EF. So if AB is congruent to CD and CD is congruent to EF. Because of this common link of CD, then I can say that segment AB is also congruent to segment EF. It's getting messier than we're situated. So CD was our common link between those other two entities, so we could link them together through the transitive property of congruence. Any questions so far? Transitive property is used a lot in these beginning proofs, so you will see that most often. All right, so now definition of congruence. If we need to go from congruence to equality, so if we know two things are congruent and then we're trying to use the segment addition postulate, we need to get into equality. Then you know that if AB, segment AB is congruent to segment CD, by definition we know that AB is equal to CD. And again, that is used when you have congruence, but we're going into an equation, we gotta flip those around. The reverse is also true. If I figured out that AB is equal to CD, but I'm trying to prove congruence, then I can switch it to segment AB is congruent to segment CD through the definition of congruence. These will make more sense as we start using them in proofs. The definition of midpoint, we already have talked about midpoint in the previous chapter. The definition says the midpoint of a segment divides a segment into two congruent parts, or equal lengths. So if you know that M is the midpoint of segment AB, you can then conclude that AM is equal to MB. You can also include equality, either one, because in the definition, it's saying congruent parts in a parentheses equal length. So you might be able to jump right to AM is equal to MB because of the way the definition is written. You have both things in there. Does everybody make sense of what I just said? Check. And looking at what you're proving and where you need to go, I would suggest using, if you're in the equation, use AM is equal to MB, so you don't have to use the definition of congruent. But if you're trying to prove congruence, then you would jump right to segment AM is congruent to segment MB. It just depends on where that proof is heading. The next one is not new. This one should feel familiar, the segment addition postulate. If A, B, and C are collinear points and B is between A and C, does anybody remember what we can conclude? What is the segment addition postulate? Mason.
A plus B equals C.
You are so close. We're not adding points though. What are we adding?
Oh, from that. AB plus B equals C.
AB plus BC. What does it equal? Mason, please go ahead.
AB plus BC equals AC.
Very good. And you're going to have to state the segment addition postulate in these proofs. So AB plus BC equals AC.